In the last tutorial, we created the first part of our project, and this project will ask the user how many days they want to work, and every day they work, it's going to give them twice as much money as it gave them the last day, and it starts the first day giving them 1 penny, which is what we've set here. So we've done all this. We've asked how many days they want to work for. We've read it into a string. We have converted that string to an integer that we can work with. So now we need to have a loop that's going to run once for every day that they want to work for, and for each day it's going to have to add the total amount of money that they have. So all we have to do right now is create a total integer that will store the total amount of money that they make, and this will equal to 0. And then we need a loop. And whatever number they gave for days, we're just going to keep decrementing that until it gets down to 0. So if they entered 0, that they want to work for 0 days, which I guess a lot of people would probably want to work for 0 days, they will end up with 0 pennies because our loop won't run. So while days is greater than 0, we need to add the number of pennies that they are going to make for this current day to the total. And basically all you have to say is total is equal to current total plus the number of pennies that they make for that day. And then we need to multiply pennies by 2. So pennies is equal to pennies times 2. So this way, every single day that this program that they work for, or every single time the loop runs, it's going to add the value of pennies to the total, and then it's going to double the amount of pennies so that it gives them twice as much the next day. And then all we have to do is decrement the days variable. So eventually they'll stop working, because no one can work forever. If everything went correctly, that should work, and all we should have to do is print out the total variable, and we should get our answer. Except we have to print it out as a floating point number because we want to convert these pennies into dollar amounts with 2 places of precision. So let's just print it out the way we normally would. And we're going to print it out as a floating point number. And we need to take the total and divide it by 100.0. We divide it by 100 so that we can convert the cents to dollars, and we need the 0.0 because we need this to use floating point division. Otherwise it's going to round off for us. It's going to truncate, it's going to hack off whatever it is to the right side of the decimal place, and we don't want it to do that. And to make sure that it uses floating point division instead of integer division, we have to have one of our numbers be a floating point number, which is why we have the 0.0. Alright, so that should do it. Let's just add a little message here. And we can put a $sign. That'll work. Alrighty, so we can run this program and hopefully it'll give us the correct answer. Now we'll run the program and I'll enter a number of 10 days. And it said we've made $10.23. Now I don't know if that's correct or not. I'll have to work out the math in a minute. But the thing that we see that's a bit odd is that there's 4 zeros. Floating point numbers by default always show 6 places of decimal precision, regardless of how many places are actually required. And there is a way using the printf function to tell it to only use a certain number of decimal places. And in this case, we only want 2, $10.23. So how do we do that? We have %f, but after the percent sign and before the type of data that we're printing out, we can specify how many decimal places of precision we want. And in this case, we say %.2f. And this tells it that it's after the decimal place that we have 2 places of precision. So %.2f will give us 2 places of precision for floating point numbers. And let's recompile this and enter 10 again and see what we get. And here we get $10.23. And because I'm lazy and I don't want to verify to make sure that $10.23 is indeed the correct amount, I am going to do something else, which is enter smaller numbers that I can do in my head. So I'm going to run this program again, and let's just say they worked for 1 day, in which case they should have 1 penny. And that works, they have 1 cent. If I say they worked for 2 days, they have 3 cents, and that makes sense. The first day they got 1, the second day they got 2, so they have a total of 3. And let's just say they worked for 4 days. And they have 15 cents if they worked for 4 days. So they got 1 cent the first day, 2 cents, 3 cents, 4 cents, and somehow we got an extra 5 cents in there. Excuse me, we didn't actually get an extra 5 cents in there. It worked out perfectly. I was thinking that it was adding 1 each day, but I forgot that I told it to double each day. So the first time we get 1 cent, then 2 cents, then we get 4 cents, and then we get 8 cents. And if you add 8, 4, 2, and 1, you do indeed get 15 cents. So we've guaranteed that this program works correctly. And let's give it a longer amount just to see, because numbers, when they double, it's amazing how quickly they grow. So if we worked for 30 days, a month, we would have a ridiculous amount of money. So starting out, if you were working a job like this, it wouldn't seem like it was very much money, but after a month, you would have $10,737,418.23. Alright, well, in this tutorial we created a pretty cool program. It's not exactly a project like I said it would be, but it did take 2 parts, and it contains quite a few features of C that we haven't used before. So I hope that you've learned a bit in this tutorial, and I'll see you again next time.